My fabulous chemistry faithful, good morning and welcome to another at-home online lecture, video number 5, redox. Today we're going to get into spontaneous reactions and being able to predict, is a reaction going to be spontaneous or not? This will be a review of what we've already learned from table J, and this will be a lot easier than what we just did in video 3 and 4, by the way. So let's get right to it. We got table J. How do we use it? We know the activity series lists metals based on their reactivity, and it shows us that the most reactive are on top and the least reactive are on the bottom. Okay, good. And the metal above is always more reactive. So I think we have some understanding of that and a little bit of history with that. That's not really anything completely new to us. So as far as this goes, a spontaneous reaction is one that will go forward without needing any energy. It will go all by itself. I just got to get those guys in contact. We learned about collision theory. We get two substances in contact, and this thing will go like crazy. When the lone metal on the reactant side is above the bonded metal on the reactant side, it will be spontaneous. So we're going to deal with single replacement reactions. There's going to be a compound and a lone metal. If the lone metal is higher than the metal that's in the compound, boom, it's going to go. And you just have to look them up on table J. And the opposite's true for a non-spontaneous reaction. This one needs energy. And so when the lone metal is below the bonded metal, then it'll be non-spontaneous. Now, the only major difference between this and our previous learning is in acids and bases. We were talking about acids will react with metals if the metal is above H. And acids will not react with the metal if the metal is below H. But so H was the starting basis spot for the first time we talked about this particular reactivity series. Today we're going to use the reactivity series, and going forward we're going to use the reactivity series with whichever two metals are present, and we're just going to look at them both up, and it's not just going to be compared to H. It's that simple. So here are a list of reactions that you need to be able to predict. Are they going to be spontaneous or not? If they are spontaneous, you actually have to perform the single replacement reaction. And if they are not spontaneous, we get to write no reaction. So let's go through it. We're going to look at the two metals. So here's what I mean by the lone metal. In this case, it's Zn. And the bonded metal is lead. And we know it's going to be the first piece of the compound anyways, because we know it goes positive, negative, and metals are losers of electrons. Is all review stuff, right? And so they go first. So I'm going to look up Zn. I'm going to look Pb up. If Zn is higher than Pb, boom, it's going to go. And if Zn is lower than Pb, it's not going to go. It's really that simple. So we're going to look up Zn. We're going to look up Pb. In this case, Zn is higher, so it will go. It will replace the Pb there, and Zn is going to hook up with the Cl. Pb is going to kick off, and I'm going to make ZnCl2. Okay? That is a single replacement reaction because I don't have the two compounds. Okay, so we're going to do another one with Zn and BO this time. So there's Zn. In this case, I'm sorry, Ba, not BO. Ba is higher than Zn, so no reaction. This is a non-spontaneous reaction that isn't going to go all by itself. We probably have to power it with electricity or something to get it to go. We need to add some energy in some way. All right, next one, CaCr. I'm going to stop underlining them now because I think you should have a feel for it. We're going to look up Ca. We're going to look up Cr. Check it. Ca is above Cr, so boom, it's going to react. I'm going to make a Cr and a CaF2. The Cr and the Ca are just going to switch. It's a single replacement. Okay, the Ca is replacing Cr. Cr is not replacing Ca. They're just left over. They're not in a compound anywhere. All right, now I'm going to look up Mn and Ni. Mn is higher than Ni, so it will go. It'll kick off the Ni, and the Mn will bond to the S. Single replacement. Got it. Next, FeMg. There's Fe. There's Mg. Mg is higher than Fe, so no reaction. The bonded metal is more reactive than the non-bonded metal, so it's not going to react. Okay, it's not going to move away. It's going to stay reacted with its I. Looking up CO, looking up PB, CO is higher than PB, so I will get a reaction, complete my single replacement reaction, and we're donezo. So this video is really just about that. We're going to use table J like we have before. We're just not going to be beholden to that H now, and it's not above H and below H. We're going to look up the two elements, and if the lone element is higher than the bonded element, We have ourselves a spontaneous reaction, guys. And with that, we are tons of